Hello everyone, this is Shashank. Now I am going to demonstrate our homework 3 project, which is the implementation of sine and cosine functions using CORDIC IP on Intel Quartus Prime Lite and Questa Sim. So to do that, first we have to go ahead and create the project name SineCos, and I've done that. And after that, we have to use the IP catalog generator to generate the CORDIC IP and change the input and output data bits to 7 and 3 respectively, and select the simulation model as Verilog. After that, it generates the .qip files and everything. Now we have to go ahead and include files in the project. So as you can see here on the left pane, I went ahead and done that. The .qip files includes the Verilog file and everything. Then separately I've included the .stc file. Now we have to go ahead and compile the whole design, which obtains the whole report as you can see here. So after compilation, go to Analysis and Synthesis and report resource usage summary. It indicates that my design uses the 141 ALMs and the 20 dedicated logic registers. Remember that depending on your pin planning, the number of registers and ALMs may change. To do the pin planning, go to Assignments and select Pin Planner. Here we have to set our pin locations for the sine and cosine values and clock pins. Depending on the pin assignments, the delay and everything changes. Go ahead and close it. After this, we have to go ahead and report our timing. To do that, double click on the timing analyzer on the left side, which opens this window. So as you can see, I have reported our timing. I've got a slack of 11.665, which is very good, from this node to this node. To report the critical path, double click on report path, click yes. So as you can see, this is my critical path from node A7 to signal 00. And I have obtained a delay of 14.177 nanoseconds, which roughly is equal to 70.65 megahertz. Once we have done with our simulation and timing, for our timing, we have to go ahead for the simulation. To do that, we need a test bench. So I have went ahead and written a test bench for this. After uploading it, click on Tools and run the RTI simulation. It opens this window. After that, click on the input parameters and click on Add to Wave. So this is the way I have obtained. So as you can see, from 0 to pi, the corresponding sine and cosine values have been plotted in this wave. So after the simulation, we have to go back to the Quartus Prime Lite and program the FPGA device. So double click on this, it's going to open this window. Once we connect the board, click on auto detect, it's going to detect the board and select the 5 device. After that, upload the .sof file, that is the bitstream file, to the device and click on start. It's going to be uploaded to the FPGA board. So now I have went ahead and dumped the program onto the FPGA board. Once I turn it on, so we can test out the output. So as you can see, the current value is pi, and I have programmed it like the upper 5 bits are for the cosine and the lower 5 bits are for the sine. So once I click this, so as you can see, sine pi is 0 and the cos minus pi is minus 1. Let's try with another example. Let's switch all things to 0. Now as you can see, when I hit this button, the cosine value is 1 and the sine value is 0. And let's try another example. Let's switch this up and let's change this and let's change this. Yeah. Now if I hit this button, as you can see, the sine 30 is 0.5 on the top 5 bits and the cosine is 0.875 from the lower 5 bits. So this is the demonstration of the CORDIC IP of sine and cosine values. Now coming to the second part of the project, we need to display sine and cosine values on the 7 segment display on the board. For that, I have went ahead and modified the Verilog code style as required and included the .qip files in the project navigator. After that, I have went ahead and set the Sine Cosine file as the top module and compiled the design. So as you can see, after the compilation, I have got the resource report. So my design is using an ALMs of total of 123, the dedicated logic registers of the count 191. And if we go to the pin planning, I have already went ahead and assigned the pins accordingly, and they have been updated on the .qsf file as well. If needed, we can directly make the changes in the .qsf file. They can be reflected here. After that, close this. And remember, depending on the pin assignment, the number of registers and ALMs may vary. After that, after the compilation, we need to do a timing analysis. In the timing analysis, I have obtained the delay of 10.193 nanoseconds, which in turn gives a delay of around 98.1 megahertz. This delay is for the critical path. To report the timing, click on Report Timing and select Report Timing. So as you can see, the slack is 16.168, which is a positive. That means we have met our slack requirement. After this, close the design and flash the code onto the FPGA board using Program Device and Open Programmer option. It's going to pop up this window. After detecting the board, select the file by clicking Edit and change the file into Sine Cos segment and flash to the board. So once we have flashed the program onto the FPGA board, so as you can see, the values have been already being displayed on 7-segment display. So right now it's displaying that by default the cosine value, cos 30 value. If I hit this button, it's going to display the sine 30 value. Let's go ahead and display our sine 0 and cos 0 values. Let's turn on this button to the 0th position. Now click this push button. So as you can see, the cos 0 value is 1 and the sine 0 value is 0. In this way, we have successfully programmed our FPGA board to detect and test our CORDIC IPs to display the sine and cos functions. Thank you.